Everyone. I'm Ishan Sharma. I'm a product manager in GKE, Google Kubernetes Engine. And I'm here to talk about some of the recent advancements that we've been doing for enhancing AI workloads on Google Cloud. I will kick it off with just a quick overview of what I'm going to be spending the next little bit speaking with you about. So first, we'll cover what customers are building with Google for their AI use cases. Then I jump into why Google Cloud is their choice for AI as an AI infrastructure provider. And then I'll talk about how Google AI Hypercomputer powers their AI journey. So we all know this since what was it, November of 2022, generative AI has become a household name. We're living in an era that's defining what happens next, right? And AI research has achieved impressive advancements and accuracy that was previously thought really impossible. And larger and more complex AI models are really getting more and more capable every day, not only in their in enhancing our understanding of the world, but also what they can generate. Everything from content generation, music, pharmaceutical research, games, robotics, recommendations, and so much more. But you all already know this, right? And you have already thought, or maybe you're thinking today, how do I bring this AI research to our enterprise workflows? And how do I boost the potential and the productivity of my team and my application so that I can really serve customers? And that's what I'm here to talk to you about. So of course, we start with the customer. We at Google Cloud are very fortunate to work with thousands of customers across many industries. Here are some of them, and a variety of use cases to transform each of our customers' businesses. Now, Google is uniquely positioned to address the needs of our customers' AI workloads. Google's research in AI dates quite a bit back, almost more than a decade. And we have over 3,000 expert researchers who have produced more than 7,000 publications that have over 2.6 billion citations and counting. We invented some of the fundamental technologies like transformer, optical circuit switch networks, application-specific chips such as the Tensor Processing Unit or TPU, which we'll talk about in a bit. We also work with open models with bringing the AI models to the public with LLMs such as PaLM and Lambda. And then our software leadership directly empowers valuable products. A lot of these are open source, like TensorFlow, Kubernetes, JAX, XLA. And we're proud to say that since 2022, Google has been the largest contributor to open source, and we're continuing along that. Now, we do have proven expertise taking AI to production with some of our applications, which you as consumers might have used, like YouTube, Maps, Search, Ads, Workspace. And in Google Cloud, we're bringing that infrastructure to you so that you are able to use those for your applications and tap into that. And so some of the things that come to mind is our world-class infrastructure, liquid cooling techniques, optical interconnects, dense data center designs. All of these are things that we provide to you. And so essentially what I would like to say and conclude is that AI is sort of in our DNA with Google. So why do customers pick Google Cloud? And first, it's really choice, and I'll speak about this in a little bit. We offer a portfolio of ultra-performant AI supercomputers for any conceivable workload, whether it is offering performance for training or cost efficiency and scalability for serving. The second part is the ability to build on a truly open and comprehensive stack. We have been models either that are developed by Google or ones that we have partnered with third parties like Anthropic. So building on of that, allowing our customers the portability and the flexibility that they desire. And the next part is around reliability and security. Glenn just spoke about some of that. But internally, we use metrics like goodput that aim to measure the true work done versus focusing on a lot of sticker numbers. So that's really what we're trying to optimize. And then the fourth is really unparalleled scale of compute in 37 regions with cutting-edge infrastructure. And finally, AI is making everything more, drawing more power, and we need to be worried about the environment as well. So with our 100% renewable energy matched globally, customers can rest assured that they're reducing their carbon emissions. So we're bringing that to our customers as well. We're honored to have 90% of the most innovative generative AI players in the world choosing to build on Google Cloud. And the companies that are most sophisticated and knowledgeable in this space are choosing us because AI, as I mentioned, is in our DNA. Coming to the AI hypercomputer, which, what is it, right? So it's really a state-of-the-art AI platform. And any state-of-the-art AI platform requires innovation and co-design across the full stack, from the layer at the bottom of hardware to software. And that's what we're providing to our customers through Google Cloud, so that you get performance, productivity, usability, cost efficiency, all of that to productize your AI hardware and to really transform the productivity of your team and your applications.
How does this differ from something like Vertex?
Vertex, that's a great question. So Vertex actually sits on top of this. So if you were to add a layer on top of it, Vertex uses this stack underneath. We announced at Google Cloud Next that Vertex AI runs on Google Kubernetes Engine, which I'll talk about in a little bit. So really, Vertex is a great example of a solution that's using the AI hypercomputer underneath. So when we talk about sort of just going layer by layer, we start with the top layer. Maybe the topmost layer, which is not shown here, is Vertex, fully managed solutions like Vertex. But then when we go to the layer that underlies that, right? That's the layer to make it simple and cost effective to consume these services that are below, right? This is highly flexible, offering highly flexible consumption models. So you might be familiar with the on-demand and the spot consumption models that are very prevalent with VMs and, of course, with GPUs. But what we recently launched is we introduced a new consumption model, Dynamic Workload Scheduler, which is DWS, which is designed specifically for AI workloads. And it's really a resource management and a job scheduling platform that's designed for the AI hypercomputer. It improves your access to AI/ML resources, helps you optimize your spend, and can really improve the experience of workloads such as training and fine-tuning jobs.
It comes something like Slurm or something like that, Array, or how is that? I mean, is that an orchestration solution or?
It's actually a solution. So it's a way to get our schedule hardware. So if you are, I'll talk about that in just a little bit in a later slide. But for example, if you're using GKE, and you are you're okay with scheduling, you're queuing your job. So we have something called queue with a K. If you use that with Dynamic Workload Scheduler, it gives you access to hardware that's scarce. So you can use flex mode or calendar mode to schedule your jobs, and you would be able to access hardware depending on what your needs would be. And I'll go. I have a slide on that, so I'll go into that in just a little bit. So with that, the next part is sort of this open software, JAX, TensorFlow, PyTorch, and that's where really GKE comes into play, which I'll deep dive into in the next couple of slides. And then finally, the bottom layer is really this performance optimized hardware. So let me dive a bit into that. So here is our comprehensive portfolio of purpose-built AI accelerators. On the left, in green, are our GPUs, and on the right are our TPUs. So here are some that are the A100s as A2, the L4s, which are as G2 VMs within Google Cloud, and our H100s, and our recently launched A3 Megas. Some that are coming up and that we have announced already are the Blackwell processors with B200 and GB200. And as you can see in in this chart, each of these provide you optionality depending on the type of workload that you're running, be it training, frontier model training, really large model training, or large model training, or smaller models. Or if you're going into inference, it allows you to choose the right option of accelerator for your needs. If you're using inference, price performance, cost is important. L4s is a great option. If you're doing training, H100s is a great option. If you're doing multi-host training, H100 provides some unique features that allow you to do that. With TPUs, our V4, V5E, and our V5P are great options for again, training or inference, depending on what the needs of your workload are. So wide variety and optionality for you. We just, as we had announced at Next, we recently launched A3 Mega, which is our latest VM instance for H100, built on H100 GPUs. So speaking about that, A3 family, which has A3s and A3 Megas, is our most powerful GPU offering, and it's powered by H100 GPUs from Nvidia. A3 VMs provide a 10x increase in networking and a 3x improvement in training performance over A2 instances. And as I mentioned, the A3 Megas, which you can now access on Google Cloud, both through GKE and GCE, they provide a 2x GPU to GPU networking bandwidth performance improvement over A3 instances. A bit about our networking. A3 is able to operate at scale and scaling to tens of thousands of H100 GPUs, can be banded together and work as one. And in GKE, you can use GPU Direct, TCPX, TCPXO networking for A3 and A3 Mega, respectively, to really access for multi-host training and multi-host inference.
So each A3 Mega or something like that would have a single H100 instance associated with it, and then you could cluster them together to do model parallelism or data parallelism, depending on what's needed?
Correct. And H100, the key difference between A3 Megas and A3s are the number of network interface cards that are there. So using that, we have doubled the network interface.
Are you using like NVLink, or is this your own solution, or?
These are our own NICs that we have, and TCPX or GPU Direct is the way to access that through an orchestrator like GKE.
Are you going to get into, when you say large model, are you going to actually get into what large model means in terms of number of parameters?
Yeah, actually, that's a session that's later on. Brandon is going to be speaking about that, and he has some fantastic demos on that. So yeah, he'll get into that.
Thanks.
Great. The next one I just want to touch on briefly, and this is a little old news, but this is something unique that we were the first cloud to offer Nvidia's L4 GPUs. This is under the family that starts with a G, and G was really named for Gen AI and graphics. So our G2 is sort of our most versatile GPU offering that offers compatibility or offers the ability to run a bunch of different use cases from virtual workstations to games. And it's really our follow-on to T4 and provides 2 to 4x performance improvement depending on your workload. So going into specifics, for generative AI, 2.5x performance improvement. For games, 3.3x performance improvement. For digital twin, 4x performance improvement compared to T4s.
Let me maybe get ahead of you.
Yes.
Usually when I start talking, it's the next slide. But in this case, no.
Okay.
How am I buying this? Is it purely through, machine types? Is it, or, Vertex is an obvious option? How am I implementing this? How closely can I get to that top of the stack there when I buy it?
Absolutely. So there are a couple of options if depending on your needs. So let me start with orchestrator. So Vertex AI is, of course, an option. I'm actually going to go to the next slide, which was perfect.
See? It worked again.
Perfect. So here, these are sort of the ways you would be able to access. So maybe I'll talk about this, right? So Google Kubernetes Engine, I'll go into deep dive into it in just a little bit. That's one of the ways to access all of this through GKE. You can provision your nodes on each of these GPUs, on each of these VMs.
And that looks kind of like the lowest level at which I can.
There is another lower level, which is if you want to directly provision VMs on VMs, you can access through our Google Compute Engine API.
Oh,
You would
okay.
be able to create A3, A2, G2 VMs.
Great.
Yeah, yeah. So you have full control over that if that's what your workload desires, or that's yours. One thing I just skipped over briefly was TPUs. So this is Google TPUs. Each version brings enhancements. For example, with version 3, we introduced liquid cooling. With version 4, we added optically reconfigurable networking. Version 5E for E for efficiency, training and serving, and P for performance. So this continues on, and
So are TPUs supported under Torch as well as TensorFlow, or?
TPUs are supported with PyTorch and TensorFlow. Yeah, yeah. I have a slide on that as well. Just speaking about Trillium, Trillium you might have heard that was announced very recently. It's 4.7 the compute performance per chip and 2 times the improvement in inter-chip interconnect. And so that's our next generation beyond V5P that is not on this chart, but just wanted to share that. So let me deep dive now into that question that was asked about how do you consume this. So if you look at GKE, that's sort of this stack right here. Maybe let's start with the voice of the customer. So why would any customer want to use GKE for this? So there's some key points that customers have shared with us, right? One is accelerators continue to remain in short supply. So you want optionality, portability, customizability. You want to be able to train and serve the models across multiple clouds, maybe on-prem. And for this, you want the freedom to write code once and run it everywhere. So GKE is built on Kubernetes, which offers you that. The next part is complexities of managing heterogeneous workloads, global teams, and multiple accelerator types. So, whether you're training massive models with hundreds of billions of parameters, or you are serving those models eventually, having a single platform to be able to run both of those is really important to your platform admin teams. And finally, most importantly, training, fine-tuning, inference, all of that is very expensive. So you want lower cost, you want higher efficiency, and you want to reduce the day-to operations and want an overall lower cost of ownership. So GKE is really that platform of choice that allows you to do all of that with AI workloads. And how do we do that? First, within GKE, just looking at the signals, the AI workload has established itself as the leading workload within Google Kubernetes Engine. And this is over the last year, the use of GPUs and TPUs on GKE has grown more than 900%. That's a lot. So customers are adopting GKE. And as I mentioned earlier, our Google state-of-the-art, fully managed AI platform, Vertex AI, is built on Google Kubernetes Engine. So why do so many customers choose GKE for their AI workloads? It's really because GKE allows customers to have a more consistent and robust development process by having a single platform, single layer for all of their workloads, be it training, fine-tuning, inference serving, or any of the traditional microservices that you might be running to serve your apps.
So can we
Yeah.
pause for a sec?
Absolutely.
We're seeing the platforms like PyTorch, TensorFlow, et cetera, these low-level development platforms for getting to AI. And then at the higher end, we have Vertex that's built on top of this platform. Depending on where I need to enter, also increases the complexity of managing the piece. If I just want turnkey AI solutions, Vertex.
Yes.
If I want to build my AI platform, this is the solution that we're talking about. But I want to drill down on this consistent and robust experience. Like from a practice perspective, getting environments to be consistent is probably the outside of talent, it is the number one challenge I'm seeing customers face. Like AI environments are fragile. Every time you make a driver update, etc., the thing breaks. So where is GKE on that spectrum of configurability, nerd knobs, versus simplicity of ease of use of environment? Like, are you protecting me from making mistakes like installing the wrong driver? Or do I have a higher level control where I can install the wrong driver and possibly gain performance, but break the environment?
Great question. And I think your question had at least two components to it. The first was around how do you have consistency across your deployment environments, which is incredibly important, especially because of capacity constraints and multi-cloud strategies, et cetera. In that case, Kubernetes, open source, widely used across different clouds. Most have a managed cloud offering. Plus, talent pool loves to work on Kubernetes. That provides running on Kubernetes. That abstraction layer makes it easier to be portable and flexible and run across multiple clouds. So that's the answer to your first question. If you were to go with a solution that locks you in, that becomes incredibly difficult, right? So this abstraction of Kubernetes makes it a lot easier. The second question is around what does it help me? What does it protect me against? So within GKE, there are two modes of operation. One is GKE standard, and the other one is GKE autopilot. Both of these support GPUs. So if you're looking for a more fully managed experience, but not as fully managed as Vertex AI, you still want control over your deployments and your scheduling. GKE Autopilot is a great environment to run it. It provides best-in-class security. It's hardened. The billing model works, et cetera. And William would have spoken to you about that. Mm-hmm. The other one is GKE Standard, where you have more knobs that you can go. You can play, go deeper into it. You can configure things. You could probably break things as well if you wanted to, but it's still more managed, right? So that's kind of the key.
So how does one access the AI hypercomputer versus a standard GKE cluster of nodes and stuff like that? Because I mean, the Hyper has all these software packages, JAX, TensorFlow, PyTorch, all these things that associated with AI activity. That's all embedded in quote unquote the AI hypercomputer. When I fire up GKE, do I say I want a hypercomputer, or how does this play out?
So within the user experience itself, yes, there's certain ways like you can go within. So first, let's take a step back, right? If you want to go deploy, there are blueprints that we are making available, that we have made available to customers that allow you to deploy hypercomputer environments.
Oh, okay.
So that's kind of the way that we're doing it. One of these is HPC Toolkit. So that's one of the ways to do it. So it's really around the blueprints, it's best practices, it's what are the components that you put around your GKE clusters. There's no, as of now, there isn't any one button where you go and you click and you have a hypercomputer that's scaled up, because what we have learned from customers is that one size fits all does not really fit all. Customers want their unique.
So if I'm doing GKE and I want an A3 mega instance or something like that, does that sort of automatically bring in the rest of the hypercomputer software stack?
It doesn't bring all of it if you go provision it from that part, but we do have blueprints and user guides that let you configure it in that way. For example, if you wanted to run multi-host training, you would create an A3 mega, you would create that instance. You would then install GPU Direct, TCPX, configure all of that. You might want to configure queue for your job scheduling, dynamic workload scheduler. So all of these things work in tandem to give you that experience for your needs.
So is it fair to say that the AI hypercomputer is really much more like a validated design? Here's a set of things you can go do, but it's not a product that we can push a button and say, hey, I want an AI hypercomputer, give me an instance of this, and it comes pre-configured. It's much more of a design guidelines?
It's design guidelines. It's configured. Again, with the blueprints, it's configured in a way that we think in an opinionated way would cater to your needs. But again, we give you the flexibility to go and change things because that's what our
right. But when you say it's configured in a way, is there something I can do to say, Google, I want a AI hypercomputer, an instance of an AI hypercomputer, and I'd select that like I do with C3 or whatever,
No,
and it says, here it is. I have to go and assemble the pieces based on the guidelines and say, here's what I need. I need a Kubernetes instance that looks like this with access to the hardware, the accelerators, and then I'm going to grab this software stack based on your recommendations.
Exactly.
Okay.
Exactly.
And the software stack is automatically updated and maintained by GKE in autopilot mode or something like that?
In autopilot mode, yes. In GKE, you can set on auto updates. So yes, for both. But again, it depends on the workloads. A lot of customers actually don't want updates for a certain amount of times when they're running training jobs, right? So they can configure that, and we have options for that as well. For inference, they wouldn't want certain sets of, they would want a minimum disruption.
Yeah.
So there's all of that. And so there are means to configure. This is actually one of probably a good answer to how you would configure all of this on GKE, right? So this is the bottom layer. You have optionality to go and access any of these. In fact, inference and CPUs works well for a large portion. You have auto scaling, placement, provisioning, job queuing, job scheduling as sort of the next level on top of that, or next layer on top of it. And then you have fleet team management, workload acceleration. Then you come into this the Q, Ray, Kubeflow, Spark, Nemo, all of those options. And then you get to the top where you're really abstracting away and how are you deploying all of these. So that's Jupyter Notebooks and batch inference and training, et cetera. So that's kind of how we think of the whole stack.
And Vertex is sitting there
Vertex,
somewhere in the middle of that.
Vertex is up there.
Oh, on top of all that.
Yeah, because it uses these features. And that's the way we know it works. Yeah. Yeah. Let me talk a little bit about training first. Really, this is about looking at just the training workloads, right? So I talked about diverse hardware. Here is a quote from our customer on being able to access a diverse set of hardware depending on what the needs are, whether it's price performance or throughput, et cetera, or accelerating the time to train models. Here's some specs or stats rather. If you look at what we can do with GPUs and TPUs, for GK provides the orchestration layer to really seamlessly manage compute. And it's powered by industry-leading support for 15,000 nodes, so quite a large number, in a single cluster to train the largest models. And multi-slice TPU configurations on GK allow chaining together multiple TPU slices so that they can function together to train a single model. And GK supports, with multi-slice TPU slices, GK supports more than 50,000 TPU chips, all training as one in training a single ML model. And that's based on TPU v5e chips. Character AI, for example, as a reference, uses GKE to efficiently train their very largest and most capable models at scale that was previously not possible, so that, again, their customers can craft personalized AI for every moment of their day. So really providing value. Now, for large-scale training, I spoke about good put earlier. So what helps? So good put really is defined as how much of the time is being utilized for doing good work or something that's adding value. So it's a combination of how long it takes to start up. It's a combination of how often are you actually using and your compute is not sitting idle. And the third factor in that is when you're using it, you're optimizing and utilizing the most of your underlying compute power. So all of those things together, we are working on maximizing good put, and that's a metric that we also use internally and track. So some of the things that help with that is 300 pods per second scheduling, container image streaming, container image preloading with secondary boot disks, which helps your pod start up much quicker, and disruption management, which enable customers to achieve levels of good put that are necessarily for these tightly coupled AI workloads, training workloads. Giving an example, with image streaming, IP Rally was able to accelerate the startup time for their training job, training job after submission by 20%. So So some really powerful improvements there. Now, I spoke about Q with a K and DWS earlier in my response to a question. So what is Q, for those who might not be familiar with it? It's a Kubernetes native job queuing system, which makes it easier for customers to manage the limited compute capabilities that are being shared across multiple teams. So it not only prevents bottlenecks, where training scripts really have to wait for GPU or TPU resources to be free. But when you combine it with Dynamic Workload Scheduler, DWS, it really gives you access to more capacity of the accelerators, provided that you can wait in a queue. So this is where, when we talk about AI hypercomputer and things coming together, this is sort of an example of stacking features to be able to deliver hypercompute capabilities. Now, Q can be used with any Kubernetes distribution. But it's better on GKE because DWS is natively supported. And if you enable auto scaling, then US customers get access to more capacity, and you can achieve better resource utilization. And hence, all of that results in better price performance without any
And so
special
Q and
setup.
dynamic workload scheduling
Yep.
really refers to the jobs that I would submit as an organization to my hypercomputer cluster. It's not like you're sharing my hypercomputer with other users and using Q and DWS to maintain it in an optimum fashion.
Right. It's yours. It's within what you're assigned. And
The presumption is I've got multiple training jobs and things I want to try to run a larger organization. I got you.
Usually platform admins work with so many different teams. Some are running training, large models, small models, some are fine tuning, all of that, right? And GKE really helps make that easy.
So how do we, I'm sorry, Alistair, how do we combine this along with what we heard earlier from the storage team, the cache anywhere? So as I'm, if I'm a platform architect and I'm thinking through how to make as much AI compute available at the best price per dollar, I'm thinking through where the workloads can run, what regions, when can it run, how can I schedule it, how can I divide, how do I provide the platform? Is like DWS aware of cache anywhere, multi-region compute?
Yeah. So DWS works with compute. And so that's where the limitations are. So it's really built out of the capacity constraints with GPUs, right? And then storage and networking kind of come along for the ride, is how I would think about it, right? So speaking of DWS, right, what it really lets you get, and actually, yeah, this slide is perfect for that. So thanks for queuing that up. It gives you access to really guaranteed capacity when you reserve either long-term usage commitments, but let's say you have short-term bursty workloads that you also need. And typically you would use on-demand instances for those short-term bursty workloads. But what if they're not available, like is often the case with accelerators? That's where the calendar mode and the flex mode can really help. So for predictable fine-tuning or predetermined training, there's calendar mode. You know that next week you're going to be running a training job that lasts this long. Calendar mode is the way to go. For running experiments with no specific time pressure, okay, I want to run this is R&D, we have the flex start mode, right? And the advantage here is that these instances provide economics like spot instances, which are not preemptible once started, right? So these have an access to a broader pool because you are giving us the flexibility to go and find it and schedule. So that's kind of how it benefits.
So with future reservations, is this literally the option of saying, hey, 3 months from now, I want this amount of compute.
Yeah.
And then my developer can just submit the job, and then I know it'll run 3 months from now when I have the compute.
Exactly. And as you can imagine, that helps us. Knowing your needs, it helps us do what we need to do internally to make that happen, rather than not giving you any impact and you asking for it a couple weeks before that's due, you need the capacity and us not being able to provide. So it works in all of our benefits, and that's really the key part. How am I doing on time?
We're a little behind.
Okay.
We're a little behind, but just keep going. It's cool.
Okay. I just want to spend just maybe 4 minutes speaking about inference, right? And as I spoke about how GKE enables both training and inference, let's speak about inference for just a little bit. And here, customers want cost efficiency, customers want scalability, customers still want high performance, right? So how do we do that? So Kubernetes is the foundation for inference, and I think there was a question earlier about this. So if you're using Cloud GPU, PyTorch is sort of your framework, Cloud TPU, JAX, and PyTorch. So I think that answers your question. And then the inference stack here is we have a couple options for both GPU and Jetstream for TPU. So with this, and this is all something, all of these frameworks you can run on a GKE, and this we work really hard to give customers the choice of framework that they can run that their team is most skilled at or that meets their needs. So now I just want to talk through just a couple of different features that also we're building for inference. So, idle time and driving down costs is very important. Some of the features that we have built here is rapid node startup, image streaming, integration with GCS views, speaking about integration with storage and networking options, parallel store to speed up applications. For example, speaking of GCS views, OpenX have really improved their model load times by 40% with GCS views on GKE. Now, Brandon later is going to speak a little bit about some of the other, he's going to deep dive into some of the other features that are mentioned here that he will deep dive into some of those.
So training doesn't support parallel store
These are all options that are available to you, whether you're using training
or inference.
Inference or microservices even. It's just that we have separated those into these features make sense for training, these features make sense for inference, based on usage patterns. GPU sharing. There, again, for efficiency, for inference, we provide several different options. These are all generally available now. Multi-instance GPUs, where you can take a GPU, slice it into 7 partitions, use that. They are hardware isolated, so it prevents hardware faults, etc. GPU time sharing, which allows you to time share across so that you're never wasting GPUs sitting around and reducing idle time. These are really good for situations where you have the flexibility of starting some processes later on rather than on time, so you're okay with latency. Multi-process service is software-based isolation. Again, it's probably prone to hardware faults. However, if you have a very strict requirement that processes need to start, you would choose multi-process service over time sharing.
Does TPU support any of these sorts of things?
These are GPU.
I understand.
Features,
Does TPU have anything like this?
TPU has other features that do that. These are mostly for GPUs because
I understand.
Yeah,
These are all Nvidia solutions.
exactly. And then the last thing that I have is just a shout out to autopilot. I spoke that briefly in answering a question about it. If you are looking for a more managed solution, autopilot with all of its benefits that you've already heard about and its ability to access GPUs on demand and spot is a great solution. So autopilot is a great solution to get started with. Of course, standard is available if you need that fine-grained control.